Okay, today I wanted to look at just graphing a piecewise function, and you're going to see piecewise functions a little bit all throughout Unit 1 in Applied Calculus. So I definitely want to go over those, and if you have your calculator, definitely get your calculator. I'll show you how you can graph these on your calculator as well. But this one right here just has two linear pieces to it. So this is like a piecewise function that's active. For the top part, it has like 5x plus 3. It's active on that piece from, when x is less than 0. So when x is negative values. And then it's active, it looks like the line 2x plus 7 when you have x values that are greater than or equal to 0. So what I do is, I just graph each one of these lines individually. So let's look at the 5x plus 3 line first and graph it. And what I do whenever I graph the piecewise is I just dot it in at first, and then later I'll go back and shade like what actually is the real graph, like the real one I'll darken in more, where it's active basically. So 5x plus 3, this one of course has a y-intercept of 0, 3. So it hits the y-axis at 0, 3. And then it has a slope of 5 over 1. So there's your slope right there. So I'm just going to use my my point and my slope to generate the line. So what we got here, 0, 3, coming down to my graph here, just to look at what I want to graph, 0, 3. And then I want to rise 5, so 1, 2, 3, 4, 5, and then I want to run 1. You'll be right here. So when you rise 5, run 1, you'll have a point right there. And of course, I can't go up any further. I can't go 5 up again. So I'm going to go down 5 from that one original point. So I want to go down 5. So 1, 2, 3, 4, 5. Basically, I'm doing this motion right here, down 5. And then, of course, you want to go left 1 if you go down. So you'll go back this way right there. Okay. So you should have, there's 3 points, and you can generate other points too if you need to. But anyway, that's what you want to have, something that looks like this. And now I'm just going to dot this in for now. Let me, 1, 2, 3, 4, 5. I'm just going to do one more point here. And then I'm going to dot this in. So this is that top function. It'll be something like that line right there. Okay. And then the other one, let me try to do this in a different color here. The other line, we'll do it like with green. Okay, the bottom line is y equals 2x plus 7, or the bottom graph is 2x plus 7. It's a line as well, just like the other one was. This one has a y-intercept of 7, so it starts at, the point, I want to start at 0, 7, and then it has a slope of 2, rise 2, run 1. So I want to start at 7, right here, and then rise 2, run 1, rise 2, run 1. You'll be like right here-ish. If you go down and back 1, that works. So just jot you in some points, and then you have your line right here. I'm just going to make it dotted though. Okay. Now, to get the actual graph, so there's what you have originally right there. Let me zoom in over here to just our picture. So if you look here, let's go back to the original, the first one, the 5x plus 3. It's only active when x is less than 0. So that's going to be values that are back this way. So like x's that are less than 0, like they're the the negative values, right? You're going to darken your graph anywhere in the negative region, in the negative x. So it will look like this. I'm just going to try to make it as darkened in as possible. So this one is only active back this way. And it goes up to, it's less than 0, so it goes up to this y-intercept right here. But it's like an open circle at it, so it doesn't actually touch that point right there. It's like it goes really close to it and it doesn't touch it. So the rest of this, the dotted part that's past that, I'm just going to erase that part of the line, and that's the only part of the graph that we have active right there. So it looks like that right there. And then let's go to the green one now. You want to color in where it's active. It's active for x greater than or equal to 0. So it's actually going to be right here starting at that y-intercept, but it's going to be the values where x is positive. So all these values in here, all these points in here have x's that would be positive. You know, like right here, this. Or let me try to like right here, this point right here, that's 1, 9, right? So 1, 9. So that positive 1, right? You know, you have positive x values everywhere along this direction. So what does that mean for, you know, this section of the graph, like this section of the green? Well, that it's not active. It's gone. So it's ignored. The graph is not applied. So I just want to erase that. And basically, those two pieces right there is what your graph is going to end up looking like. So, you know, if you want to draw you a little grid of it, just to kind of like give yourself an idea of what's going on. So let me just draw like a little sketch here of what you're seeing. Okay, this will be your y, and this will be your x-axis right here. And then your graph basically looks something like this. You have this piece right here that kind of goes off this direction. And then a little bit further below, when you're going to the left, you'll have a piece that kind of starts right here and goes back this direction. So your piecewise function kind of looks like that right there for this situation. Now I want to show you real quick how to do this if you're using the calculator, because it is an interesting thing to do on the calculator to graph these. One thing I would do too is before you graph anything is just to make sure that you have nothing in the y equal spot at all. So make sure all your y equals are clear of anything. And it's kind of a weird way you have to do this, but you're basically going to put each piece in parentheses. So I'm going to put that top piece in parentheses, 5x plus 3. So I open parentheses, 5x plus 3, and then close parentheses. Now, what you're going to do is you're going to divide, and then open set parentheses again. You're actually going to do like a logic argument here. You're basically going to do whatever the logic statement is for like x less than 0. So here's how you'll pull up that menu for the logic stuff. Do your x value, and we want to do x when x is less than 0. This is what we want to graph. So it's right here under math. If you do, or above math, it's the test menu. So hit second and math, it'll get you to that blue stuff. And when you want to do x is less than 0. And basically your logic, you know, when you're doing those logic or those test values, it's either going to be a 1 or a 0 if it's true or false. So basically what you're doing is whenever x is less than 0, so whenever x is negative, it'll be true, it'll be a 1 or whatever. You're basically dividing by 1 like each time, which it gives you the same thing. It gives you 5x plus 3. But then whenever x is greater than 0, I'll have to show you in a table menu, but whenever x is greater than or equal to 0, you're actually going to have a 0 that you divide by, which you can't divide by 0, so it'll give you like this error message, and I'll show you what that looks like in a table. But anyway, you want to do the same thing for the second piece then. The second piece was the 2x plus 7, and then I want to divide by, this one is when x is greater than or equal to 0. So do your parentheses, x, and then do second math, or get to the test menu, and you want to do greater than or equal to 0. Okay. And just one thing I want to show you right quick with the table, which I use the table a lot when I'm doing calculus problems, just because it's easy to use. But go here where it says table setup. It's above window. Hit second and table set. Make sure on the independent, this is really the only thing you have to change from the default. Just make sure your independent variable is on the ask part when you do your table setup. That way you can actually input your x values that you want. Okay. So now I'm going to go to table. It's right above graph. So before we graph it, I just want to show you this. But second and then table. And I'm just going to put in some various x values kind of around 0. So like -2, -1, 0, 1, 2. That's good enough. So if you look here, just to kind of show you what's happening with your graph, when x is negative, or sorry, it's those first two right there, right? When x is negative, the only piece that's active is that top piece, and it's the first piece we entered. So right there you can see it's active, but then when you go into positive x values, that one stops being active, so you get an error message the way we set it up. But then the second piece becomes active, so you see it has numbers now. So it's very easy way to do this. And then when you hit graph, it may take you a little bit to like play around with the window just to see where the graph is. But when you hit graph, yeah, you can kind of see it on this. Like it comes in down there and it kind of disappears and starts back up there. And the only downside to using a graphing calculator like this is you can't really see those little open circles where, like, it looks like it comes right up to the y-axis and touches it, but you'd have to zoom in really, really close to see the pixel stop right before you get to this axis. So anyway, it's interesting to see, but it takes a long time to zoom that far in. So I would just make sure at 0 this piece stops. So put a little open circle, and then the other piece is equal to 0, the second piece. So you'll have a solid circle on that green piece right there. But anyway, that's how you do the piecewise defined functions.